Okay, I thought I would just show how the auto calibration is currently working. So here we have slide printer simulation, HP sim running on my local host. It's getting G codes through the WebSocket. I have this program, Active Calibrate. It will tell the slide printer to make some movement, collect some data, and then it will run an optimization and try to figure out where the anchors are step by step. So you will see how it works. Let's see, this found my previous data, so let's create a new data file. My active. So we force it to actually collect some data. Now I drove the mover using torque mode because it doesn't know where anchors are, so it can't actually move the mover in a controlled way in Cartesian space. So now we're moving in the inverse space, drawing circle sectors around every anchor. This will work in higher dimensions as well for 3D hand printers and for hand printers with lots of anchors, like 8 anchors. It will still work. So try to use the fact that there's a known relationship between how line lengths can actually behave when there are stationary anchors like this. You get this circle sector, but you also get an elliptical relationship between the other line lengths. So here we have collected the data using 3 sweeps. We have guessed that anchors are here, which is very close to the actual placements. So 1900 would be the correct line lengths, and it found 2.6 millimeters too long here, exactly the right here, and 2 millimeters too long there. And it suggests to make a new sweep with this score, which is a low score, but so it guesses that the improvement won't be very large if we do another sweep, but it has a suggestion to make this sweep, keeping anchor 2 fixed. Anchor 2 is this one, and it will have a target length of 600, so it will lengthen that line by 600 millimeters and make a sweep over here. We can say, sure, collect next sweep by pressing C, even though it doesn't look like we need it. Let's just show you how it works. So I told it to collect more data, and it tries to collect the optimal data. It calculated that moving here is the optimal strategy for improving the score. Let's see how that actually works. Finished. And the actual optimization is super fast with this new method, so close to 0 here. We can see if the new cost is lower than the previous cost. And it actually is. So that means the new anchors are actually better. The new found anchors. These were the old ones, and these are the new ones. we can just look at, we got 1902, 1901, and 1901, which is very similar to what we got before. The correct number here is 0. Correct one here is 1900. I think the correct one here is 164545. So we're like 1 millimeter off. And it's the 950 is the correct number here. We're getting very close. Let's collect a couple more sweeps just to show that it works. So in a real life scenario, it would actually talk to the physical machine and tell the physical machine to go to the optimal spot and collect the optimal data to learn more about the geometry of the machine. And the data collection would be slower. As you can see here, I'm running the simulation at 16 times real time. We'll be waiting for several minutes for each sweep. It always returns to the origin so that it's ready to make the next collection. Did we lower the cost again? Yes, we did. We are actually getting closer and closer. Let's collect another sweep. Curious how it will look, how these coming sweeps will look, because here we don't have the 600 number anymore. We have shorter sweeps. That's kind of a separate optimization that it runs, trying to find out where the improvement would be the highest. Let's see, collected the new data. It managed to once again lower the cost function. Sweep just because it's fun. I guess in real life we would just have accepted the first one because it was already so good. Okay, he thinks it's most important to collect data right here. You can see a slightly brighter spot wherever it stops and collects data. Okay. Accept anchors. The cost is now 0.006, which is super low. Accepted anchors. Great. This is that new anchor config.